Hello and welcome to this video lesson on part 9 of our logarithm chapter. We're going to be walking through some review problems that we've seen over the course of this chapter of different kinds of equations and word problems that we're going to be solving. There are quite a few problems on here that will be good practice, but we're not going to go through all of them in this video, only about 5 or 6 of them. I will be posting the answer key for all of them to go along with this assignment so you can try these for yourself and check to see if you're doing them correctly as review for our tests next week. Remember that our tests will be happening on Monday and Wednesday, with Tuesday being our ACT testing day and not having class. So let's go into our first problem that we're going to be working on. So that is going to be problem number 3 that we see in front of us here. It's a word problem. And this is going to be exponential growth. So we have a equation 30 times 0.85 to the power of t, because this is going to be exponential decay by about 15% per hour. So that's telling us that our t is in hours. And we're trying to see how many hours are going to have gone by the time we have 15 milligrams of the caffeine in our system. And this is something you could apply to any medicine, not just caffeine, or any kind of medicine or drug of any kind that a pharmacist might consider in their job. So let's go into our steps. We're trying to see when our equation is going to be equal to 15. And so we would write our equation equal to 15 like so. And so basically we're looking at like when are we going to have half of it in our system if we're starting out with 30 milligrams. So if I divide both sides by 30, that means that I would have 1/2 is equal to 0.85 to the power of t. And so the easiest way to approach this problem from here would be to rewrite it as a logarithm. So we would have log of base 0.85 of 1/2 equal to t. And then we're going to use our change of base formula, or you can use the log base function on your calculator to basically write out our answer as the log of 1/2 divided by the log of 0.85. No matter what method you do, you'd end up as that being your answer, basically. And so that in our calculator, if you do the log of 1/2 divided by the log of 0.85, you get an answer of 4.27. And that is hours. So it would take about 4.27 to have your 30 milligrams of caffeine down to only 15 milligrams. And I mean, you could kind of expand that to being, well, how many milligrams of caffeine are in 1 cup of coffee? Think about how long it takes caffeine to exit your system. I don't actually know the answer to that, so that'd be something to keep in mind, I guess. So 4 is basically kind of a pretty easy problem if you use our change of base formula. We're just doing the log of 100, or the big number, divided by the log of the little number. And that's definitely by far the easiest way. And sometimes you'll have something like log of 100, but we just equals 2, since 10 to the second power is equal to 100. So you could do 2 divided by the log of 5 if you find that easier to have part of it just be a regular number. So if we do 2 divided by the log of 5, you would get that your x answer is 2.86. And we can move on from that problem and move to number 5. So number 5, we have natural logarithms with our ln instead of regular logarithms. When you have 2 logarithms, and they can be natural logs like this, and you're adding them together, you can multiply the inputs. So I'm going to do 5x minus 3 times 2, and that's going to give me 10x minus 6. And then that's going to be equal to the natural log of 24 minus 2x. When you have a logarithm of any kind on both sides and nothing else outside of it, we can set the insides equal to each other. That means the 10x minus 6 and 24 minus 2x are equal. We just need to solve this for x. So I would add 2x to both sides to get 12x and add 6 to both sides to get 30. And that means that x would be 30 over 12 or 2.5. And we can always check our answers in our problem to see if we did it right, but it is in fact the correct answer. All right, so those are our first 3 problems so far. Moving to the back, we have another word problem in number 7 that we'll be doing next. So the Richter scale is actually something that they use logarithms to figure out that the magnitude of earthquakes is logarithmic in that your energy released would be your x-axis, and then your y-axis would be where you are on the Richter scale. I mean, it turns out that a lot of the time they're not using the Richter scale quite as much anymore, but that's not really important right this second. So I want to solve this equation for E. In order to do that, I need to get rid of the 2/3 first. So I'm going to multiply by 3/2. So I would grab my calculator and do 6.6 times 3/2. That would get rid of my 2/3 right there. Multiplying it by 3/2 equals 1. So now I have 9.9 is equal to the log of E over 10 to the 11.8. Now we can convert it to a logarithm because this is a common log, so it's a 10 on the bottom. So I would be able to write that as 10 to the power of 9.9 is equal to E divided by 10 to the power of 11.8. So I'm going to multiply both sides by 10 to the 11.8. So if we grab our calculator, we can do 10 to the power of 9.9 times 10 to the power of 11.8. So we get that answer with an E involved there. So what that means that we should do with that E value is that scientific notation on your calculator. So that means that when we multiply these two numbers right here, we would get that answer. So that answer is 5.012. And this E to the 21 just means times 10 to the 21. And that is going to be equal to E. So you can see that, well, we have a very big amount of energy being released, 21 zeros after 5, or, well, after 0, 1, and 2, when I rounded it, you would have, I guess, 18 more zeros after that. So that's a lot of energy. And so that's like for a 6.6. So Richter scale keeps going up from there. So you can imagine how bad it would be in that case. All right, moving to number 10 on this video here. Number 10, so we're looking at fruit flies. Their population is growing at a rate of 28% per day. They have really quick turnaround and that sort of thing. They have really short lives overall. So they were starting out with 25 fruit flies, going up by 28%. And we're trying to see when it's going to be equal to 100. So similar to our problem before, we can set it equal to 28 or 25 times 1.28 to the t like that. So I would divide by 25 on both sides, giving me a 4 equal to 1.28 t. So we could do what we did before with our common base formula, but let's practice using logarithms on both sides. So I would do the log of both sides, or in other words, I would be doing log of 4 and then log of 1.28 to the t. My next step would be moving my exponent to the front and using our power rule. So I would have the log of 4 is equal to t times the log of 1.28. And then I would just be dividing by this logarithm on the right, which means my answer is the log of 4 divided by the log of 1.28 equals t. And then I would just grab my calculator and do that answer there. And so the calculator tells me it's 5.62. And we're talking about days. So they are quadrupling in population after only about a little over 5.5 days, which is pretty fast. Number 11 is next. Log base x of 5 equal 1/4. So we would be doing x to the 1/4 equals 5. So in order to solve this the easiest way possible, we're going to use exponent rules. I'm going to raise both sides to the power of 4. So when you raise a power to a power, like on the left side here, you just multiply the exponents. 1/4 times 4 equals 1. And then we just need to do 5 to the 4th power in our calculator to get the answer of 625. So number 11 is not necessarily that challenging steps-wise, but knowing how to solve something like x to the power of 1/4 is not necessarily something that might be very familiar. And that finishes page 2 of the problems that we'll do together. Moving to our last page of problems, we're going to do 12 and 19. So 12 is sort of a weird problem in that it's an exponential equation, but both sides have exponents. So you don't want to make it harder than it needs to be, basically. So we want to just do 5 to the power of 2.3 in our calculator, which means we would have 3 to the x is equal to 40.516. And I'm just keeping the thousands place just so I don't have to worry about rounding too much. And so then I would just convert it to a logarithm for the easiest way to do this. Base 3 of 40.156, like so. And then I would probably use the change of base formula. So I would do the log of 40.516 divided by the log of 3 and throw that in my calculator. And we get an answer for x of 3.37. Moving to our last problem of the video, number 19 at the bottom here. So we have a lot of extra stuff going on here. So we're going to be using that kind of log on both sides method from earlier in a problem. Whenever you have an equation like this, you want to get rid of everything outside of the base and power, and then just the one number on the other side. So I got to subtract 3 first as my very first step. So I have 343. So we're going to do this basically 2 ways. So the first way, we're going to do logarithms on both sides. So I would have the log of 7 to the 3x plus 1 equal to the log of 343. So this power, for a power rule, moves to the front. So I have now 3x plus 1, and then log of 7, and then log of 343. Hopefully that's not too hard to see. What that says is 3x plus 1 log of 7 equals log of 343. Now, from here, I divide both sides by this log of 7. That would leave me with just 3x plus 1 on the left side and the log of 343 over log of 7 on the right side. But we still have to get rid of the 3 and the plus 1. So I would subtract 1 first, giving me 3x, and then the same log fraction here that I already have going on. And then I just have a minus 1 on the end. And now I'm just going to divide this fraction and this 1 by that 3 right there, which would give me that x is the log of 343 divided by the log of 7. And then I would have a little 3 on the bottom of that fraction. And then I would have a minus 1 over 3. So it could be on an ACT test or on a final exam that the answer is going to be in terms of logarithms, this exact answer, rather than what the decimal would be for it. If you put that into your calculator, we would be doing the log of 343 divided by, in parentheses, 3 times the log of 7, in parentheses, and then subtracting 1/3. We get 0.66 repeating, or 2/3. But that's not the only way to do this. We've also learned how to solve exponential equations. They are the same base. So now that we've kind of done all that work right there to get the answer of 2/3, let's do it a different way. So we had 7 to the power of 3x plus 1 equal to 343. It turns out that, as you can see on my calculator, that 7 to the third power actually equals 343. So that means that I could write this as 7 to the 3x plus 1 equal to 7 cubed. And then I can see that there's a 7 on the bottom of both sides. So that means that 3x plus 1 and 3 have to be equal. So I would have just some solving equations to do from there to get the same answer of 2/3. And that is our final problem of this video. I will be finishing the answer key for the rest of the other problems we didn't finish and posting that along with this classwork as review problems from the whole chapter, and expect some other review posted to prepare you for your tests next week. And with that, we will end the video. Thank you very much for watching.